water reservoirs, slowly melting glaciers are reshaping U.S. river systems and water supplies, posing severe long-term risks for agriculture, hydropower, and millions of people. Glaciers act as natural water reservoirs, slowly releasing meltwater into rivers and streams throughout the year, ensuring a steady flow. As global temperatures rise, glaciers in the Rocky Mountains, Sierra Nevada, Alaska, and the Pacific Northwest are retreating at alarming rates. Many of the most important U.S. rivers, including the Colorado, Missouri, Columbia, and Snake rivers, rely heavily on glacial meltwater. Glacier-fed rivers are essential for drinking water, agriculture, industry, and ecosystems, making their decline a critical issue. The Colorado River, which supplies water to 40 million people across 7 states, is experiencing reduced flow as upstream glaciers shrink. A significant portion of the Columbia River's summer flow originates from glacial melt, feeding into hydroelectric dams and irrigation systems. In Montana's Glacier National Park, over 70% of the park's glaciers have vanished since the early 1900s, altering local river dynamics. Reduced glacial melt means less water for agriculture, forcing farmers to rely more on groundwater and artificial irrigation. As glaciers melt rapidly, temporary surges in river flow occur, but these are followed by long-term reductions as ice reserves disappear. Hydrologists warn that permanent water shortages could occur in glacier-dependent regions, increasing reliance on water imports and conservation efforts. Alaska's glaciers contribute billions of gallons of freshwater annually to rivers like the Yukon and Copper rivers, supporting fisheries and wildlife. Increased glacial melting raises flood risks by overloading river systems, causing sudden and unpredictable surges. Glacier loss also increases sediment flow into rivers, leading to clogged water channels, ecosystem disruptions, and infrastructure damage. The disappearance of glaciers threatens hydropower generation, as lower river flows reduce energy output from major dams. Many power plants in the Pacific Northwest depend on glacier-fed rivers to generate electricity, making energy supplies less reliable. As rivers warm due to reduced glacial melt, oxygen levels decline, threatening fish species such as trout, salmon, and steelhead. The loss of cold glacial water in rivers is disrupting spawning cycles, leading to declining fish populations and economic losses for fishing industries. The Columbia River salmon population, already stressed by dams and pollution, faces additional threats as glacier-fed waters dwindle. Some indigenous communities in Alaska and the Pacific Northwest depend on glacial-fed rivers for drinking water, fishing, and cultural traditions. Water managers are increasingly concerned about declining snowpack, which usually supplements glacier melt but is also shrinking due to rising temperatures. Glacier meltwater has historically provided a buffer against droughts, but as glaciers disappear, regions are left more vulnerable to prolonged dry spells. Parts of California, Arizona, and Nevada are seeing increasing water shortages as glacier-fed river levels drop. In the Sierra Nevada, glaciers play a crucial role in replenishing reservoirs, but their rapid decline is forcing water districts to explore alternative sources. The Yellowstone River, fed by high-altitude glaciers, is experiencing reduced summer flows, impacting tourism, wildlife, and agriculture. Climate change models predict that many smaller glaciers in the U.S. will disappear by 2050, permanently altering local hydrology. Some rivers are becoming more seasonal, with extreme fluctuations between high spring melt and dangerously low summer flows. Glacial retreat can also destabilize mountain slopes, increasing the risk of rockslides and glacial outburst floods that can destroy communities downstream. As glaciers recede, wetland habitats that rely on steady meltwater are drying up, reducing biodiversity in river ecosystems. Scientists warn that melting glaciers will contribute to rising sea levels, affecting coastal freshwater supplies as saltwater intrudes into river mouths. Saltwater intrusion threatens estuaries and freshwater aquifers, making drinking water sources near coastal cities more vulnerable to contamination. Researchers are exploring artificial solutions such as glacier preservation techniques, including reflective blankets to slow melting. Some cities are investing in desalination technology and groundwater banking to compensate for lost glacier-fed water supplies. States like Colorado and Montana are implementing water conservation policies, encouraging efficient irrigation and stricter water use regulations. Glacier-fed rivers provide essential habitats for migratory birds, amphibians, and mammals, all of which are now facing habitat loss. Hydroelectric projects may need redesigning or relocating, as river flows become less predictable and reservoirs struggle to retain water. Increased glacier melting leads to more landslides and erosion, which can damage bridges, roads, and water infrastructure near major rivers. The Missouri River Basin, which supplies drinking water and irrigation to much of the Midwest, could see severe water shortages as upstream glaciers vanish. Glacier loss is contributing to extreme weather events, as altered water cycles influence storm intensity, flooding, and prolonged droughts. Water conflicts between states, farmers, and urban centers are expected to rise as glacier-fed water sources diminish. Some scientists suggest redirecting seasonal floodwaters into underground reservoirs, creating artificial storage to compensate for glacier loss. Reservoir managers are experimenting with drought-resistant water policies, requiring more precise river flow predictions and stricter usage regulations. Without glacial melt, many U.S. rivers may become more dependent on unpredictable rainfall, making droughts harder to manage. Alaska's rapidly retreating glaciers are reshaping the state's ecosystems, fisheries, and even the cultural practices of native communities. Conservation groups are advocating for expanded wetland protection, as wetlands act as natural buffers against water shortages. Water shortages will increase costs for agriculture, leading to higher food prices and economic instability in farming regions. Wildfires are becoming more frequent near glacier-fed rivers, as reduced water flow creates drier landscapes and fuels extreme fire conditions. Emergency planners are preparing for more glacier-related disasters, including sudden glacial lake outburst floods that can wipe out infrastructure. Some scientists propose reinforcing high-altitude reservoirs to trap seasonal meltwater before it escapes into the ocean. Hydrologists stress the need for comprehensive water-sharing agreements, ensuring that cities, farmers, and industries can adapt to declining glacier melt. As glaciers disappear, the U.S. must rethink its entire approach to water security, prioritizing sustainable management of remaining freshwater resources. The long-term loss of glacier-fed water is one of the greatest challenges facing U.S. river systems, requiring immediate action from policymakers and scientists. Without intervention, the impact of glacier melt on water supply, agriculture, energy, and ecosystems will reshape the American landscape for generations to come.